Hi, good evening, everyone. It's nice to meet you all here again today. Thanks for joining us tonight. So I'm Joyce, and today with my colleagues, we run the StackX DevRel work here in GovTech. So before we start, we would like to run through a couple of house rules that are currently up on the screen. Yes. Okay, so first note that this webinar is being recorded, and we ask that your questions be kept to the topics presented today to keep the session meaningful. And finally, please feel free to ask questions throughout the webinar via the Q&A function at the bottom or perhaps top of the screen for some of you. And please kindly refrain from posting questions in the main chat as our speakers wouldn't be able to take questions from there. And next slide. So tonight, we are very excited to have the GovTech cybersecurity team with us. Rong Hua, Keith, Jing Lun, and Kelvin will talk about security in the Internet of Things. So the first sharing by Keith and Jing Lun after Rong Hua's opening will focus on how hackers can exploit vulnerabilities in an IoT ecosystem. And the next sharing by Kelvin will touch on the possible security measures that device manufacturers can adopt to improve the security posture of their products. So before we invite our speakers to share, here's just a very quick intro on us. Next slide, please. Yep, thank you. So our GovTech is now about 3,000 strong, and our work can be broadly classified into these three areas: products, services, cyber, and governance. So for products, we have over 700 developers who implement products for the WOG and develop strategic national products. We also have capability centers in digital services, sensors and IoT, data science and AI, cybersecurity and infrastructure. So the products team actually manages the whole of government infrastructure, from our move to commercial cloud to data centers to even the issuance of devices to all public offices. And the services group is the biggest of the three actually, making up more than half of our staff. And they play a very important role in managing technology in over 60% of government agencies in Singapore. And finally, cyber and governance. So we are the sector lead for cybersecurity in the government, and the Chief Information Security Officer sits in GovTech. So to ensure all the work we do is safe and secure, our governance group sets ICT policies and guidelines across the whole of the Singapore government. So to engage and connect with our developers, engineers, and techies like yourselves, GovTech actually formed the StackX community in 2019. So if you have not joined, you can scan the QR code on screen to do so. I'll also share the link to join our StackX meetup community. So here's the link here. Yep. And we actually share the latest information on deep dive StackX sessions with government and private sector professionals who share on a wide range of tech and tech-related topics. And updates on our latest meetups will also be shared with our community members. So this platform is a really great way to stay informed about GovTech's products and engineering news. So I'm also sure that you'll discover our dev portal or developer portal contains content that's very useful. So you can visit us and discover the products that we have developed. So this includes National Digital Identity, API Gateway, DevOps products, and documentation that you can actually try out. So our community page also is available, where you will find the videos on demands of past webinars, as well as blogs by our GovTech teams. And the dev portal is actually now in the beta phase, so we really ask for your patience as information is being onboarded. And if you have any feedback, please let us know. We'd love to hear from you. Yep. So maybe now invite Rong Hua, the Director for Advanced Cybersecurity Capabilities, to give an introduction and also share a bit about our topics this evening. Rong Hua, please. Thank you.
Nice. Hi everyone, my name is Rong Hua, and I'm very grateful to everyone here for your support, where you have invested your precious time this evening, attending this sharing session by GovTech. Just a quick introduction. The speakers, Keith Tay, Goh Jing Lun, Kelvin Wong, and myself are from GovTech Cybersecurity Group. In short, CSG. CSG is the cybersecurity lead for the government sector, and our responsibility is to secure government's ICT and smart systems such as IoT. To secure our system, we are supported by cyber specialists playing different roles. Just to list some, we have specialists continuously monitor and analyze cyber threats, conduct secure architecting for our systems, and also conduct security testing for our systems to discover vulnerabilities in a very proactive manner. This evening, we hope to share some of the learnings that we have garnered through security testing and architecting in the following topics: identifying vulnerabilities in an IoT ecosystem, as well as eliminating the root of all IoT evils. Last but not least, please feel free to share with us your feedback, and we also hope to learn from every one of you here. Thank you, and hope you have enjoyed. You'll enjoy your sharing later. Thank you very much.
Thank you, Ronghua, for the opening address. And now over to Keith and Jinglun for the first part of our sharing. This sharing topic will be a hacker's perspective of identifying vulnerabilities in an IoT ecosystem. Keith and Jinglun, thank you.
Okay, thank you, Joyce. Screen. Okay, can you all see the screen? Okay, good. So thank you all for tuning in today. So Jinglun and I will be sharing with you with regards to identifying vulnerabilities in an IoT ecosystem. Before we begin, we'd like to give a short, brief introduction of ourselves. So my name is Keith. I've been working in GovTech for approximately close to 5 years now. So I lead the IoT penetration testing team. So basically we perform security services, testing services for our whole of government. So it could be in terms of agencies or ministries level. In the evening, I'm actually an adjunct lecturer at Singapore Polytechnic. So I teach part-time adult learners on ethical hacking. A little bit about myself, hobbies. Actually, I love to learn more in regards to cybersecurity field. It's actually a very dynamic, fast-paced environment. So I love to do research. I love to learn more, and I guess also to share that knowledge with all of you here. So Jinglun, a little bit about yourself, introduction.
Okay, thanks, Keith. Yeah, so hi everyone, I'm Jinglun, and I'm also in the IoT pen testing team alongside with Keith. So my focus is really on testing the IoT wireless technologies such as Bluetooth, Zigbee. Yep, so I hope everybody here will enjoy today's sharing. And also if anybody here is interested to share your experiences in this field, I think we'll be more than happy to connect. Yep, back to you, Keith.
Okay, thank you, Jinglun. Okay, so the key objective for this sharing is really to share your three things. The first of which is to show you all some of the threat landscape of IoT ecosystems today. The second of which is actually our key agenda, is to really share insights on how can you go about testing for vulnerabilities in an IoT ecosystem. Last but not least, we want to share and introduce you a tool called OWASP ISPS, which can be used by anybody, be it if you're a developer, you're an architect, you're a security tester. These documents are actually really very relevant to you. So we'll go more into that later. So this is the agenda that we're covering. Without further ado, let's go to the introduction. Okay, so I'm sure most of us today, we all know that IoT devices are actually growing at a really steady rate. We look at some of the research that are published, it's actually expected that in 2024, there's actually expected to have 13.8 billion number of devices. So looking at the past charts, you can see that this is actually a steadily growing, increasing rate of devices. So why are there getting more and more devices? I guess if you look around, be it locally or overseas, you can see a huge reliance of these devices are actually used to fuel our smart city initiatives. I think today, we're trying to make our lives easier, better, more convenient through the use of IoT device. So everything becomes more and more smart. We talk about smart transportation, smart manufacturing, smart health, basically everything is getting more and more smart. So because of that huge demand, these devices are starting to get more and more capable. In a sense that if you open IoT devices today, you can actually even find Linux embedded operating system actually installed in them. So what that means is that they actually have the capability to process data and to even store data within them as well. And likewise, IoT devices are actually meant to be connecting to other devices and even communicating back to the internet. So you get to see common technologies used, for example, Wi-Fi, BLE, Bluetooth, 4G, and even 5G carrier. So with this huge demand and these devices becoming more and more capable, it starts to become a prime target for hackers as these technologies are all starting to converge with modern tech. So let's look at some articles out there today that shows how IoT devices or even ecosystems are actually being compromised. So in this first article here, 2 years ago, there was this vulnerability that was found on Xiaomi pet feeders. So basically, a pet feeder is, if you're traveling abroad, you can actually automate certain feeding time for your pets. So attackers were actually able to find a back-end flaw and in which they can actually remotely control these devices. So assuming you place certain timing to feed your pet, these attackers can actually prevent these operations from actually even happening. So the devastating impact could be your pet who actually starve over time, which is actually really, really very bad. The second of which I think has been gaining traction, I think, is the privacy concerns. So what you see on this screenshot over here is actually a Shodan search engine. It's actually it's actually a very good search engine tool to search for IPv4, any devices with IPv4 addresses and stuff. So simply by using your search filter queries, so this I did it last month, we're actually able to see that there's actually still a lot of devices, even in Singapore, the IP cameras are still available to be viewed by anybody in public. So I think this is actually the key root cause is actually really due to using default credentials. So this is really a huge concern to public in terms of privacy. The next of which is actually an article which I chanced upon a couple of weeks ago. So this is really interesting. Basically, a casino got hacked through a fish tank thermometer. So what the details actually mentioned was that hackers, they were actually able to exfiltrate the high roller database tables and then exfiltrating this data out using the fish tank thermometer. So because of this, it started a lot of conversations with regards to what about IoT devices that are actually deployed to operations technology environment, basically OT. So in short, OT actually stands for, I think good examples are like your water plants, your electric grids, your manufacturing plants and stuff. All of them actually rely on the use of some IoT devices to automate certain events from happening. So a very good example is that, let's say if your systems rely, for example, if it's getting too hot, you could have certain events in place that can actually perform some cooling measures. But if attackers are actually able to tamper or modify these data readings, that is actually something that could really lead to very devastating impact. For example, it could actually cause the systems to overheat. It could actually lead to explosions and eventually leading to national security. So all in all, cyber attacks on IoT devices today are actually trending, and the impact really vary depending on where you actually deploy these devices in your environment. What do you actually use them for? So some of the key motivations of why people actually go about targeting IoT ecosystems today, briefly, is actually really profit. Hackers out there, they are actually really looking for vulnerabilities which they can sell in the dark web. I think that's how they go about earning more profits in their next of which is actually the privacy for intelligence. So I think, the IP camera was a very good example of how can you go about eavesdropping people's conversation or even looking at people over the internet. Last but not least, I think the last 2 points, I think the fish tank thermometer was another good example of how you can actually make use of IoT devices, these smart devices, to actually pivot into other organizations' internal network. Then from there, you take out the data and then you exfiltrate them out using these smart devices back to the internet. So all of these are actually really a huge concern and a threat today. Okay, so if you look at architecture for IoT ecosystems, I'm sure traditionally if we design web applications, most of us will actually be concerned with creating like web application logic, data store, and some of your back-end controls that you have in place. But when we talk about IoT ecosystem as a whole, we're actually introducing way more nodes than what you actually know. So if you look on the left, all of the orange circles are actually denoting your IoT devices. So imagine if you are rolling out thousands of devices, then that actually opens up huge attack surfaces on your entire organization. So likewise, you have IoT gateway that does the communication between the cloud and back to the IoT gateway itself. So which brings us to our key topic today. How can you go about identifying vulnerabilities in an IoT ecosystem? Basically in these 2 points. First of which, we will target on the IoT device and gateway. And the second of which is the supporting infrastructure of IoT ecosystem. So on the first point, identifying vulnerabilities in a device and gateway. So looking at some of these news out in the open, security researchers managed to find vulns in Alexa and Google Home vuln, able to eavesdrop people's conversation. If you have them in your office, they could be listening to what you are discussing in meeting rooms and stuff. There are articles that also state that how hackers are able to place tiny chips on hardware boards itself to actually alter the program state or even exfiltrating data out using the hardware level itself. Furthermore, there's also all the Nintendo gaming devices where people jailbreak it. I think all in all is to give free access to firmware and software out there. So the key message is really about security researchers today are moving lower down the tech stack to identify vulnerabilities. So you could be spending a huge investment on your existing infrastructure, but if you do not adequately protect your IoT device today, that could actually still result in the compromise of the entire IoT ecosystem. So it's really important to take a look coming from IoT device angle as well. So there are actually three components when it comes to accessing IoT device and gateway security. They are actually basically hardware, firmware, and radio wireless communications. So for hardware, the key objective of what you really want to perform is to try to gain access to the proprietary or custom firmware. All in all, what you really want to do is to search for sensitive strings, keys, encryption keys that are used for communications, and many, many more. So after you extract the firmware, the next thing that you want to do is to really analyze it. So activity of what we call reverse engineering. So what we really want to do is to identify insecure coding practices in which an attacker can actually exploit from them. And then once you have found a vulnerability, the key thing of what you really want to do is to pair up with the necessary hardware, the right frequency, and then using crafting your malicious payloads to attack other IoT devices and gateway out in the open. Okay, so maybe this video will depict or is a better representation of what I've actually explained earlier. So it's a video that we created in-house. A typical setup, there's a light, there's an IoT gateway, and then you have your mobile application to control these devices. So the first step of what you want to do is to really open up the device, start doing hardware hacking. So the first thing, like what I mentioned, is to try to gain access to the firmware of the operating system. So identify areas in which you can actually perform serial communication on. So we soldered some pins and then we plug it through certain ports so that we can actually perform serial readings on the laptop device itself. So what we did was to identify the baud rate, and then subsequently using the serial communication to look at the boot up message, and then subsequently gaining shell access to the operating system itself. So in this case, we're actually able to gain as a root user, and basically a root user means you're a full privileged user. So from there, we were actually able to extract out the firmware. And then from here, we're actually able to identify the encryption key that was used in the network operations. So the network encryption key, that means that you can actually decrypt packet, you can encrypt packet. So what we did was to pair with a software-defined radio. We create our own custom script. And basically what we are going to do here is that we are going to take over the device that was already connected to the IoT gateway. So all in all, what we are doing is to let the device know that, hey, you should change your frequency and then connect it to the root device that you've actually set up. So that's how we actually remotely take over a light bulb, and then we control it by toggling its on and off features. So imagine if your neighbor is actually conducting this attack in your home itself. So in the middle of the night, if your lights suddenly turn on and off, I think that could be really spooky as well. Moving on to the next slide, just a little bit details of how can you go about testing for vulnerabilities in IoT device. The first of which I mentioned is hardware. So what you really want to do is to identify various, are there any debug ports made available on the hardware device itself? So some of the common ones are like UART, SWD and stuff. So all you want to do is to try to communicate with it, dump out the firmware, or try to gain access to the operating system. If you do not see these pins and pads, that's what you see on the picture, you in the red box, then the next thing that you need to do is to really understand and identify the hardware chips on the board. So go up to look up for the data sheet, and then from there really start to identify which are the pins and links that you should actually connect to communicate with it. So in our case, we were actually able to gain a shell access, and from there, with access to the operating system, what we want to do next is to perform enumeration. So what we are really looking for is things like sensitive files, like your private keys used for encryption, certificates, staging production URLs, and communicating back to the cloud, or even passwords. All in all, you should really look for the custom or proprietary firmware that does most of the logic analyzing processing of the device itself. So once you extract it out, the key thing of what you want to do, there are new two key paths. The first of which is to really reverse engineer or analyze the firmware to try to identify insecure coding practices where you can actually exploit them to cause erratic behaviors. So some of our past engagement experience was that we're actually able to bring down other devices on the network, or even being able to perform some sort of unauthorized read and write on other devices itself. The second path is also to look for intentional backdoors. I think IoT devices today, they actually created, so that, if you face certain problems, we call for support and help. There are some remote support that can actually remotely connect to your device and then perform some form of diagnostic updates. And because of this is actually a double-edged sword. If a hacker managed to identify this feature, it could actually be used by hackers to access your device and phone as well. So that's something of concern. So from here, if we find some sort of vulnerabilities, the next thing that we really want to do is to craft our malicious packets. So imagine if it's actually using ZigBee, using BLE, you need to understand the packet structure, make use of the relevant radio frequency hardware device and then crafting the packet and sending it over the air. That's how you can actually perform communication with other devices as well. So all in all, if I can summarize the entire testing process for IoT device and gateway, is to always start off with the hardware level itself. There are two things that you want to do. First is to extract useful information such as keys that are used for operations, staging production URLs, and even certificates as well. The next is actually to identify vulnerabilities in the firmware, so due to insecure coding practices. So all in all, what you want to do is then exploit these vulnerabilities by using the necessary hardware tools. So what are the radio frequency channels that they're using, and from there craft your malicious packets to exploit other vulnerabilities. So in the second half, later on, Jing-Lun will be sharing the second part, which is how can you go about compromising the cloud packet. So you'll see some very, very relevant articles about how most IoT ecosystems are also compromised based on lack of protections on the API endpoints itself. So with all this information, basically hardware testing can actually provide you a wealth of information used in further attacks in the entire ecosystem. So all in all, security testing tip for this portion is to really, number one, extract out the firmware that's actually used for the device. What you really, there are various methods that you can go about doing so. One is either you extract it out like a hardware. Two is you sniff it when it's actually performing a software update. And the last is actually, you can actually try to go online to the manufacturer's download site to actually download the firmware itself. Then the next step that you want to perform is to really reverse engineer it, analyze it, to look for insecure coding practices so that you can actually exploit them on over the net. Okay, so I will hand it over to Jing-Lun to actually share a bit more about the second portion, which is how can you go about attacking the infrastructure. Jing-Lun, please.
Okay, thanks, Keith. Okay, I'm seeing my screen, sorry.
Yep.
Okay. Yep, okay, so thanks, Keith, for sharing about the attack vectors of the IoT device. So on to the second part. Well, I think IoT isn't just really about the hardware devices. So a big part of it revolves around the internet, I think, as you have known from the I in IoT. So while we want to look into the weaknesses of the hardware devices, I think we also do not want to miss out looking into the supporting infrastructure for the IoT ecosystem, such as the web API servers and front-end applications, because often than not, we will also find security vulnerabilities in them. And in fact, actually, vulnerabilities related to the API servers could often lead to devastating impacts in the entire ecosystem. So one example here would be a smart lock solution. I think its back-end API servers were vulnerable to this insecure direct object reference attacks, and hence attackers were able to retrieve the unique decryption keys of your physical smart lock by tricking the API servers, and then they were able to unlock your supposedly secure smart lock without your permission. I think another similar example here would be a baby monitor system where the attackers were able to abuse the API servers to gain access to your private baby monitor streams. And I think that is definitely not what we want. Or how about discovering that a web server actually dumps out sensitive information for your routers to everybody else, such as your device IDs or MAC addresses. So I think all in all, data breaches, denial of functionalities, and remote takeover of your device ownerships. They are just some examples to list, as you can see in the few snippets here. And based on our past experiences, I think a fair share of vulnerabilities discovered from our assessments, they do really stem from the backend supporting infrastructure. With regards to IoT assessments more specifically, the top 3 API vulns that we commonly observe are one, excessive info disclosure from your server response, unauthorized access or modification by tampering with the request parameters, and lastly, command injection on IoT gateways to achieve remote code execution, also known as RCE, or data exfiltration. So to demonstrate how these vulns could actually surface and impact an IoT ecosystem, we had early on designed this IoT dashboard application with some vulnerabilities embedded within. We actually used this to conduct a technical workshop in the annual Stack Developer Conference, I think late last year. So I think allow me to quickly just share a bit of the technicalities of the top 3 vulns that we mentioned earlier. So for excessive information disclosure, while the front end may only just display information pertinent to the user, but sometimes we note that the back end may actually return more information because data filtering was only done in the front end. So in this example, you see that the user has access to view the gateway component, and he's only allowed to see his own gateway. But during testing, a simple check against your HTTP request could reveal hints of information disclosure. So here you see that the web server actually returns information of other gateways to the client also, because filtering is only done in the front end. So this information could actually serve as a very useful information to the attackers, because they can use this to do subsequent attacks. Yeah, so you see that you can actually see the gateway information of other gateways like 002, 03, and its related devices. The next commonly observed bound is about gaining unauthorized access to data by modifying your request parameters. So due to insecure designs, sometimes it could be really possible to just access resources that by right are not allowed to the user, just by modifying your request parameters to bypass the business logic. So in this example here, we see how the attacker was able to change the profile details of a victim just by knowing the victim's username. And this username could be perhaps retrieved from the earlier attack due to like some information disclosure bounds. So here you see that the victim's name was actually modified without the permission of the victim. And lastly, to share a bit more about command injection attacks, I think command injection attacks are also rather prevalent in IoT applications, as there's often a gateway component with smarter computational powers in IoT setup. Often it comes with a remote connectivity for us to perform some intended system commands. So this could result in opportunities for us to bypass around the input validation to perform RCE via command injection techniques. So here in the example, we see how the attacker was able to smuggle a Linux command due to some improper sanitization efforts by the API server, and then thus being able to retrieve the etc password file. Yeah, so you can see the attempt here to retrieve sensitive information from the gateway. So now with this way to exploit and perform remote code execution, the attacker can then now really start to perform some serious attacks at your system by using this compromised gateway as a pivotal point into your network. So maybe you can draw a parallel to the earlier example about the fish tank thermometer. So you see like how being able to compromise one small part can perhaps lead to a more devastating impact. So to sum them up, it is really important that us as developers and system owners, we really have to recognize these common vulnerabilities so to ensure that we do not deliver our products with these loopholes. A good tip here would be to take reference to our OWASP security testing guides, as they are very, very comprehensive, and they cover things over like web, API, mobile security, and IoT security as well. And for the testers, I think we need to recognize that the supporting systems are just as important to dive into, not just the hardware devices when we come and talk about IoT, especially the client-facing applications. So dedicating effort on them, such as doing proper pen testing and source code reviews, this could really help to sieve out the potential vulnerabilities. And then this bounds, if when chained across the entire ecosystem, along with other discovered vulnerabilities from the hardware side, it could often really lead to a demonstration of greater impact. Yep, so before we wrap up the first session, I think we also want to share a very useful resource. So the OWASP IoT Security Verification Standard, also known as the ISVS in short, this is an open source standard that helps us to define the security requirements for IoT applications. So the requirements provided by the ISVS can be used at many stages during your development life cycle, so including like design, development, and even testing of the IoT applications. Because we know, IoT is composed of many interconnected applications, and sometimes, more often than not, they come together to form a very complex ecosystem. So really, when we talk about securing an IoT application, it really boils down to securing the entire ecosystem. So the ISVS actually helps us by specifying 5 sets of security requirements, and it covers areas across the entire ecosystem with reference to existing industry standards as much as possible. For each set of requirements, I think the ISVS actually describes 3 security verification levels, with each level increasing in depth. So each level contains a set of requirements mapped to some security sensitive capabilities and features. And then here is just a look into one of the set of requirements. So you can see that it's actually built like a bit as a checklist, which can be easily referred to. And there are some ways that we can make use of the ISVS to improve the security posture of our applications. One, we can see to use it as a metric. We can use it as a metric to benchmark and baseline our application's posture against others. We can also use it as guidance during all phases, such as design, development, and testing. And lastly, we can also use the ISVS during our procurement phase to help define our requirements before we engage our vendors. So while it may be challenging to some to try to incorporate this ISVS concept into your projects, maybe consider the following 2 tips to make it easier to follow. So one is that we should recognize that some requirements may not be applicable to your projects, and it is okay not to map everything back. So you really have to evaluate them based on your needs. And also see if it is possible to tie ISVS into your risk assessment, evaluation, and threat modeling to help select the requirements that are related to your applications. And yeah, that actually wraps up our first half of the sharing. I hope it was enjoyable and rather educational to all of you. If not, then back to you, Joyce. Thank you.
Hey, thanks, Keith. Thanks, Jing Lun. Okay, I think that that was a really insightful sharing on the disastrous impact that hackers can actually have on all IoT systems. So to all tuning into our StackX Meetup now, feel free to continue submitting your questions via the Q&A panel. We are still taking all your questions from the floor. And now may we invite Kelvin, who will be talking about the risks and security considerations of a smart device concept and the importance of getting the requirements right at the start of a product development life cycle. So Kelvin, the spotlight is yours.
Thanks, Joyce. Let me share the slides first. Can you see the slide? Okay, yeah, thanks. Yep, thanks, Keith and Jing Lun, for the first session. Good evening, everyone, and hope you have learned something new from the first session. I'm Kelvin, and tonight I'm here to share more from the other perspective on how we can protect our devices as we build them, and also to make sure that we nip the problem in the bud and eliminate the root of all things evil, things here being IoT. So a bit about myself. I'm currently a security consultant for Smart Nation Sensor Platform, or SNSP in short, at GovTech, supporting the security aspects, which mainly dwells into the IoT and cloud technologies. So it's only for me, in the past few years, I've actually picked up cloud, where I've gotten my AWS SA certification. But most of my career I've actually spent as an embedded software engineer, building car radio systems, HVAC systems in the automotive industry, and also did a bit of design work and implementation on aircraft EW radar systems. So I've mainly dealt with real-time operating systems and designing drivers for microcontrollers. So here I am thinking that maybe I'll share some of the practices that's related to cybersecurity and how to ensure your products are secure as you build them. So to that, I'll be covering mainly from the perspective of a manufacturer or IoT device developer. So firstly, to highlight the risks that may arise from a smart device concept, to also share the importance of getting your requirements right for security as you develop your product, and also to share on the possible security measures that device manufacturers can take note of and adopt. Okay, so to that, I'll be the agenda for today would be I'll just do a quick recap on the vulnerabilities in IoT devices, touching on the approach on security by design for device lifecycle development, and lastly, to secure the IoT ecosystem. So let's start with a recap of what Keith and Jing Lun shared with us earlier. So for that, with so many vulnerabilities you come across or read from the news of devices getting hacked and thus leading to data leaks or loss of personal data, what can we do? So how can we ensure that our products don't have weird spy chips implanted before the product hits the market? Or worse, attackers may even exploit the device as a means of getting into your organization's enterprise system to gain access to confidential data, like your users' data, just like the casino example that Keith shared. So for that, let's just go briefly into the anatomy of a device. So a device actually comprises of many parts, as earlier mentioned, your hardware, firmware, radio comms. All parts of a device can actually be hacked or reverse engineered to get information about your product. Then of course you may ask, are you sure? how about housing? So not so much for a light bulb, but for other things like your smartphone, physical security is actually a requirement. So just like how Apple designed their smartphone, you need certain tools to actually get it open. So with that, how do we approach security by design for IoT device lifecycle development? So I recommend a 5-step approach. We'll go through step by step along the way. And first, we'll start with the first one, which is actually to know your product and what you're building and identify the security risks. So why do we start with this? At this point, we have to ask ourselves, how much are we willing to spend to build your device? So say if the device costs $10, how much of that is actually attributed to security? $8, 80 cents? So yeah, it's about the cost. And to determine that, it's actually best to do a cost-benefit analysis. And for that to happen, you need to know what the risks are. So risks can be mainly categorized into 3 areas. Organization risks, meaning if your product is hacked, what the organization may lose. And I don't mean reputation and trust, of course, also is the consideration, but what I actually mean is that they allow entry to your enterprise system. Secondly, your user risk. So if your product is hacked, what may the user lose? Personal data, payment details. And lastly, if the product is hacked, what does it do to your product roadmap? Does it mean you have to redesign your whole product line? So the more risks you identify, of course, the more controls you need to be in place. The lesser the risk, the lesser the controls. But then, of course, if it's too little controls, then the consequences will come, hopefully sooner than later. So in understanding the product that you want to build, you may have to ask yourself some of these questions. What operating system does it use? Does it have an RTOS, or does it not have any OS? What data does it collect and or store? Personal data, keys. How does it interact with the environment and the user? Is it part of the environment, or is it a consumer product? Does it connect to the internet? Okay, this is an obvious question. Of course it is, or else we won't call it IoT. Okay, so what's your product roadmap? Meaning how many variants you want to spin off from the base product, and what features are available? Meaning different features that come with different releases. So an example here would be a smart TV. So you can like have a Linux type OS with the admin account, also to store app data as well as to cache browsing data. You also want it to access the internet via the Ethernet or Wi-Fi connectivity from the user's home. Maybe for the roadmap wise, it can be used for the next 5 years before you start to get people to buy your new smart TV. And also you need to store your company certificates for updates. And lastly, some of the other functions like install new apps conveniently, read from USB drives for photo and videos, cast screen from mobile devices. So now that you know what your product is and what is your requirements, you identify your security risks. So here are some of the security risks surrounding a smart TV. So for example, there is a chance of losing the OS admin password. There's a chance of losing your user's privacy. There's also a chance of losing your user's accounts and passwords, or also even your own organization secret, which is like your certificate. The users decide to tamper with the smart TV to try to redo some reverse engineering, and in turn, that might lead to discovering some of the vulnerabilities in components, and also if there's a component obsolescence, you also might have to take note of that. And due to the last 2 risks, you might have a shorter product lifespan. So all in all, these are some of the possible security risks that you might identify. So now, moving on to step 2, is actually to select the right processor and components. In other words, your BOM list. Okay, so for this step, there are actually 4 areas to consider in mitigating some of the risks that were brought up early on. The first is if there's a need for protected or secure memory space. Second, the microcontroller will also need to have a true random number generator with support of strong crypto libraries. Third, it should also have a secure boot. And lastly, the supply should be able to provide you with good technical support. Okay, for the first one, what do we mean by protected or segregated memory space? So looking at the diagram on the right, it's actually all about ensuring that the device boots into a trusted environment, running a trusted firmware. And that's what we call a trusted execution environment, TEE for short. So if you have secrets that should not be visible to unauthenticated users, we should store them here, just like your hardware group of trust. Without a TEE, basically attackers will be able to read your keys and passwords over firmware after a firmware dump. Oh yeah, so another thing, you can actually try to Google U-Bootkit and read more about it because it's about a couple of security researchers from Tencent that actually came out with this way to rootkit the IoT device to the extent that actually even pressing the reset button on the device also won't work. So how do we get this protected space? One example would be actually to have your microcontroller talk to a TPM, Trusted Platform Module, or secure element, or just simply choose a microcontroller that has a protected memory, or better yet, to have a microcontroller with added functions that secure the memory space, like a read protection function. Secondly, going to the strong cryptographic libraries, most of the time we always claim that we encrypt our data. But so what if we were to encrypt all those data, secrets, and binary firmware with encryption standard that is already broken or weak, just like your DES or SHA-1? So look for chips that can minimally support AES-128 or RSA-2048. Also, random number generators, you have to look out for TRNGs because it won't be useful if your random number generator isn't random. Okay, so now third one, we are going to something called a secure boot. So this actually works hand in hand with the protected memory space or TEE, where actually it validates the firmware image before loading or executing it. So if you have a well-hidden key, which is used to validate the hash and integrity of a firmware, you're able to ensure the authenticity of it. So the diagram here actually shows you how you can use a key pair to sign your firmware and validate it on the device end. So from the OEM side, you actually use your key to sign it, your private key to sign it, and then the system, once in the front end, the system actually tries to use the public key to derive the firmware. Okay, fourth is to actually seek help from suppliers. So don't do everything yourself. Everything has vulnerabilities. Even Intel has architectural vulnerabilities which led to Meltdown and Spectre. So it's always important to work with suppliers so that if there's any vulnerabilities found, they may have the patches for it. Don't write your own. In some cases, they may even have secure bootloaders that's already available with their components. So going on to the third step, we'll look at some quick tips on designing your hardware and firmware with the security measures. So this is a very heavy slide, so bear with me. Let's start with the firmware. So what are some of the best practices? Always ensure that you remove your test functions, debug hooks from your firmware source codes when you set it in for production. You won't want users to use those debug functions as a backdoor to your own device. Next, plan and create a secure bootloader as part of the firmware so that you don't have to depend on an emulator or flash programmer to load your firmware, and also to ensure that it loads your signed firmware. Next, if your device application takes in external inputs, remember to validate it and sanitize it before you use the data in your functions. Next, when you work on the interface requirements between the components or subsystems, or even with the physical worlds like humans or other machines, do consider what is required to be confidential so that you know what you want to encrypt, and also then ensure integrity of the data packet. This can be done using a checksum method. Like for example, the sender might send a checksum hash of the packet. Receiver verifies the checksum against the packet before accepting the whole thing. Unfortunately, I just wanted to bring the point at the bottom up that not all wireless technologies are actually secure by design. So you may need to have some design to preserve the resiliency should integrity fail. So like, for example, if you drop the packet, you may have to design something to request from the sender to resend it again. Okay, so lastly, ensure that your testing is done on the firmware, working together with the hardware. And this pretty much includes your statistical analysis, unit testing, fast testing, integrity testing, and of course, if possible, hardware pen testing. So now, going over to the hardware side, always plan and design 2 different iterations of the board, one for development, one for production. If you have confidential information like public keys, like your hardware proof of trust, send it to the chip manufacturer and load it in before shipping it for mass production. So basically, no one in between the supply chain is able to load anything to your microcontroller. Next, this may not be so necessary for everyone, but do consider the housing of your product to allow easy access only for authorized people, like for the servicing crew or the maintenance team, but difficult for users to hack open. So like my earlier example on Apple smartphones. Lastly, if your device have ports like micro USB or USB, use them only for power charging or patching only, not for your development or administrative purposes like plugging in to log in as a root or admin account. Okay, so next, down to the hardware for the electrical engineers. So these methods are actually mostly security by obscurity, which actually over time is actually breakable. But actually, it does give your attacker a hell of a hard time if break. So it's actually, it's more of like prolonging or making things more difficult. Okay, remember how I mentioned that risk assessment and cost benefit analysis are important? So a caveat here, some of these methods will definitely drive your production costs up. So again, know your production, know your product and what's it worth along with the data. So going to the first method, erase the component model name from the IC packages. Hackers can actually take a look, go to the internet, look for the data sheet so that they can try to reprogram your chip. And so by removing the name, it actually makes it harder to discern its identity. Next, design a multi-layer PCB board and hide your critical traces within the layers and make it accessible through the VS. You can see in the diagram here. So you may then ask what are considered critical. So things like your chip select pin, your chip select signal pin, or your TPM or secure element data lines. We think those are critical. And lastly, choose a chip package that doesn't have leads sticking out, so that's actually harder for attackers to probe. So some of the examples would be QFN, your quad flat no leads package, BGA, ball grid array, or another one that's not indicated here is your COB, chip on block, so which is actually just putting epoxy on top of your microcontroller. So if you remove the epoxy, the whole thing comes off. Fourth step. Okay, so you have to ensure that you have the two pros, your prototyping and your productizing. Don't use a prototype as your end product design. So for this, we want to adopt security by design based on the methodology of the product lifecycle. Starting at the component level, you have to take a prototyping approach so that it's actually cheaper to produce at the start, and then you iterate along the way. At this point, the firmware engineers will also use this board for development work as they work on the driver functions and make sure that interfaces are working before they go to production, and also to make sure that things work between components. Next, engineers will then develop firmware, do functional prototyping, and testing their own codes against the hardware. At this point, they may even have to cut traces to experiment with different GPIO pins or functions, as if the hardware was designed wrongly. Next, validate the design. Of course, now the hardware engineers will have to produce the next iteration of the prototype, validate all the errors and changes made to the prototype board, and the firmware engineers will actually design and implement the official production functions, cleaning up the debug codes, comments, test functions. And lastly, when all is validated, the final hardware version design is ready. Ready meaning that you have already removed all the test channels, the test pads, the unwanted ports. This version shall then be used for the official production assembly line to load the firmware. Of course, before you send the end product design to the assembly line for production, do a first article test to ensure that it works. Okay, so last step is actually to manage the vulnerabilities and to plan for patching. So for this, we can think of it in 4 main steps. The first, create a response plan after releasing the product into the market. This plan should actually address the risks that are not mitigated sufficiently during your development. So like what the organization should do if a compromise of the device may cause embarrassment to the organization, for example, a person data breach. Also, communicate with your component suppliers on their roadmaps and the vulnerabilities as well, since they would likely know firsthand if their own components are faulty or insecure. Next, release firmware patches as updates, or if you are really unlucky that a patch is not doable, remediate the hardware faults through the next iteration of your product. And lastly, if that's still not doable and the compromise actually causes safety concerns, then you really have to bite the bullet and recall your product. And actually, this is the reason why it's crucial to get your security requirements right up front to prevent this from happening. So next, let's touch briefly on the IoT ecosystem. So if you recall from the previous, the first session, a typical ecosystem diagram is depicted here, where you have your IoT devices communicating through a gateway back to your enterprise system. Users can also use their smartphones and PCs to connect through your system to access those devices. So where are your assets to be secured? So obviously, the data store is where you have your customers' data, your company private keys, and your company other secrets, probably. So for the ecosystem, it's pretty much the same as safeguarding any enterprise system. So I've actually generalized into the 4 main points here. First, make sure that you can onboard devices, verify their authenticity, and also be able to disconnect them if you find it behaving weirdly. Second, design your system with a secure architecture in mind and not to have your assets directly accessible by the internet. Third, always monitor your network and endpoints for anomalies so they can respond quickly. So anomalies, things like if your temperature sensor suddenly sends a few megabytes of data every 5 seconds instead of a few bytes per 10 minutes. Now that's weird. So, and fourth, always conduct security testing like VAPT to find the risks or blind spots before you go into production mode. Okay, so this is actually all I have to cover in terms of content, and hope that you can take away something new tonight. But before I end off, let me shamelessly introduce you to our CSG blog. And here you can actually check out other interesting articles that we CSG folks have taken some of time on our own to share our interests as well as knowledge with the community. Currently, IoT has actually been around for quite some number of years, but security around it hasn't really improved much because it's highly challenging to address some of these issues because of large attack surface. So remember, as engineers, we can design and produce a product. But there are also engineers out there that does the same thing and can also reverse engineer your product. Be it good intentions or bad ones, it's important that you are aware of such loopholes, take the necessary precautions, and maybe be a better engineer. Thank you. Yep. So back to you, Joyce.
Hey, thanks, Kelvin. I hope everyone gained as much as we did from our 3 speakers dive into the various aspects of IoT security, especially since it offers so many potential benefits. So at this moment, we will be going for our combined Q&A right now. So perhaps just to kick off this Q&A session, I'll start off with some questions that I have for our speakers. So, if from the hacker's perspective of identifying vulnerabilities in IoT from our first sharing, it sounds pretty scary to me in that there can be so many different types of attacks out there. So, I mean, in this case, what can I do to protect myself and my IoT devices? For instance, is my safe fridge safe to use?
Okay. Yeah, thanks for the question. I think this is a really very tricky question, to be frank. I think a lot of people often go asking, is my IoT device at home safe? How should I know whether it's safe or not? So the best recommendation that we normally tell people is often a time that is to see really the benefits to it and the risks. So I think you have to evaluate it. So how do you know whether it's safe or not? Actually, one of my key recommendations I often tell people is that try to take a look at the company's background in terms of their portfolio and stuff. We have come across companies like, for example, Xiaomi is a very good example. They have a continuous bug bounty program. In a sense, it means that they actually continually engage researchers to actually report on their vulnerabilities. If anybody found it, they will actually pay a a hefty sum of amount to these researchers. So that actually encouraged them to fix it and then to release patch to all the home device users who actually purchase their products as well. We've also seen certain products where, even if you find certain vulnerabilities, you email them, they are actually unresponsive. Then down the road, a couple of months later, you don't get a response. They may not even be supporting that product anymore. It's actually very common for IoT products that, after a while, they phase out that product, then they don't continue maintaining it. So my best recommendation is to, I think do that evaluation in terms of understanding what the protocol is about. Two is to really check out on the company's reputation, because if they have a good track record of continuously engaging the community, fixing, releasing patches and stuff, I think this is something that consumers like all of us should be aware and take into consideration.
Thanks, Keith. I'll certainly take that into consideration. So I just have another question related to yours and Jing Lun's sharing. So from your past experiences in terms of IoT pen testing, what would actually be a good tip for our fellow makers and developers on the call now?
I guess I can take the question. Yeah, so thanks, Joyce. I think your question here ties in line with some of the questions in the Q&A, like whether what can we do to protect our systems and how can we not make the same mistakes again and again. So I think from our sharing, we also have stressed a lot on the importance of secure coding and secure design. So if we can really enforce these good practices right from the start, such as by also taking reference from the industry standards like the ISVS, OOPS testing guides, then I think it will make it easier and we can be more assured to see ourselves in a better position, a better posture. And I think another tip that we can have is to perform routine testing. The keyword here is routine. So yeah, don't save it for the last and don't just do it for the formality, because more often than not, when you do it at the last and you start to realize, oh, if I have only done this earlier, I could have solved so many more hassles. And so really by nitpicking the problems right from the start, I think this helps a lot. And I think just always have security back at the back of your head when you're developing your products. I think that's one tip that we can give to our fellow makers and developers. Yeah, I hope that answers the question. Thank you.
Yes, it did. Thanks, Jing Lun. I think your tip is very useful not only for the development work, but for life as well, so that we don't procrastinate in anything at all. Okay, so I just have one more last question. This is directed at Kelvin. So what do you think is the best way to patch my devices that are already out with consumers or operationally in the field?
Thanks for the question. So for that, I guess firstly, your ecosystem must have your patch server. And with your patch servers, mainly just do patching. Don't ever mix the patch server with your web servers and stuff. Then from your device, since you have your hardware root of trust, you should be able to do your secure channel to your patch server and then to get the patches directly. So you can do it for consumer devices. Mostly they do it over the air, attach probably through your home Wi-Fi. And so with that secure channel, actually, it's encrypted. So they actually get the firmware directly from your patch server. Then from there, it does it will load the firmware through the secure hardware root of trust, your secure boot, and that's how it does the patching. Hopefully that addresses the question.
Yes, thank you so much, Kelvin. Thanks. So I think we are at the point where a lot of our participants are eager to go. So we will now open up the Q&A session to participant-submitted Q&As. So perhaps I can give the floor to Keith, Jing Lun, and as well as Kelvin to pick questions that you would like to answer now.
Thank you. Okay, so I saw there's a question from Vincent, I think basically asking what is CSG's recommendation on enforcing security of 802.11 management frames against attacks. So I guess you're coming more from targeting like performing DOS attacks on Wi-Fi networks and stuff. Okay, so I think the broader question actually boils back to the secure design part. So I think if there's a chance where you can even go way back, is Wi-Fi even supposed to be the technology that you have to use? No, and I think there's a lot of considerations. I think like what Kevin has mentioned earlier. If you're actually performing some sort of sensitive, time critical devices and stuff, it could be live at stake. Then Wi-Fi may not actually be the best option. So way in advance, if you can actually do a secure design kind of discussion, then I think that's the first element. But if Wi-Fi is really have to be used to answer your question directly, what is our stand on management frames against attacks? Okay, so in the market, there's only two kinds of solutions to it. It's either you use a 802.11w standard, or you use a WPA3 to actually prevent against management frame attacks. But with that mentioned, not all devices, be it the device itself, the client, or even the opposing end, they do have to support for such standards as well. And yeah, so I think the key thing is that you can actually prevent one kind of DOS attack, but in Wi-Fi itself, there are actually still bound to be a lot of different kinds of DOS attacks as well. So you may just be solving only one issue. There's actually still a lot of other DOS attacks that you can actually perform and still cause the same kind of resulting impact, which is to bring down the availability of the system. So yeah, so to answer your question, yeah, if you way back if you can think about is Wi-Fi supposed to be used in the environment, I think that should be considered first.
Thanks, Keith. Perhaps we can give the floor to Kelvin. Maybe you have a question that you would like to answer.
Sure. Probably I'll pick. So there's a question by Kenichi Kato, which will designing in a crypto authentication IC help in securing your IoT device? I guess what you're trying to say is something like a TPM or a secure element. So earlier mentioned, in my slide deck, I actually mentioned about TPM, secure element, or also microcontrollers that has that secure memory space. Yeah, so these are areas that, or rather components that can actually help secure your IoT device. It gives you the very basic high level of trust, making sure that things are not visible, or rather things that are not meant to be visible, invisible.
Thanks, Kelvin. Kenichi, we hope that answered your question. Perhaps Jinglong, your turn is up.
Okay, sure. Yeah, I think first of all, thanks for so many questions. I think it will be quite hard for us to answer everything here, but I think we will take in mind the questions if we have missed out any, and hopefully this will also spur as some of writing prompts for us as we continue to publish in our CSG blog. I think perhaps I'll answer the one from anonymous attendee. How easy for us, for anyone to pick resources off the internet and to try to hack IoT devices? Yeah, I think I can answer this in my position. So I would say it is not difficult. I mean, internet is really very vast in resources. We have so many things, YouTube, you even have like Udemy or even Coursera. So there are so many ways for us to gain resources in terms of cybersecurity actually. I think the key difference here when we come to talk about IoT device is that the option for opportunity, because like let's say when we talk about like web hacking, we can always easily gain access to a remote server to try our exploits. But when it comes to IoT devices, we will need to have the opportunity to really have the device in front of us. So that could be one part that makes it a bit more challenging. But of course, I would say there are definitely still resources for you to read write-ups and gain experiences from people who have done it before. And I think the open source community here is also very lively when it comes about home-based hacking. So for us, we have also managed to find our way in the internet to try to learn. But I would say comparing it to traditional web hacking, IoT hacking is, I gain a lot more from peer-based learning. So I'm quite happy to have colleagues who are experienced and in the other domains. And for one, I think when it comes to IoT, like Keith was sharing about hardware hacking, just a funny thing to share. I think my team, if they're here, I think they'll laugh also. They are not very confident of my soldering skills. And actually soldering is also one of a very important skill to have when it comes to hardware hacking. So yeah, I think team-based learning here and peer-based learning definitely helps a lot. So sometimes they help me to solder, then afterwards I can dive into the firmware and try to find more stuff. Yeah, so that's just a small difference here. I think if not, I think that IoT hacking is still quite resourceful in the internet. So yeah, I hope you can find the stuff you need. Yeah, that's all for my answer.
Okay, so maybe I pick another question. I happened to chance upon the chat. There's Andy YP Tan that posted about how can a hacker find out the model of an erase cheat. So I think this was rising from what Kelvin has mentioned about how can you deter hackers. Okay, so I have actually experienced trying to identify what is a model of an erase chip. So most of the time you will see that the chip is just black. You cannot see any contents of the device itself. So from there, what you do is actually what we call a black box testing. You know that there's actually a lot of leaks, pins, and all. So you actually have to rely on quite a number of things. I think one is you need to be comfortable using a multimeter. Then after that, it's just more about probing every single leg of it and then making a more intelligent guess. So by what I mean is that in the market or in the industry, there's only quite a number of brands that you can think about when it comes to hardware chips. So I think something like STM, the Raring and stuff. So by referencing to the data sheets online, what you're actually trying to do is that if you see a ground here, you try to map to that to the data sheet online. If this is not the one, then you move on. So it's a bit like a black box testing. You need to test the pins and stuff. So that's why I think Kelvin mentioned is a deterrence technique. It's actually true. It actually you will need more time, maybe like a couple of hours more, just to figure out which chip are you actually using. Then from there, you can actually then communicate with the device to perform the necessary hardware attacks that we have actually mentioned earlier. So hope that actually answered your question with regards about how can you go about finding the model of an erase chip.
So for me, I see there's a question from Matthew Wong. Wanted to ask the speaker what is a mitigation to denial of service on the web application supporting the IoT device, since there are lots of IoT devices. So for web applications wise, right? So this is mainly about your security on your ecosystem, the backend. Make sure that you know what exactly what's the type of traffic that you expect from the IoT device. If it's not a frequent type of data packet that's coming in, you can what you can do is actually you try to do some analysis over your network to see whether do you need to throttle the data that's coming in, so that when you see there's a load of data that's coming in, right? I think at that point of time you should suspect there's some malware infection or that the device has already been compromised. So on your backend, you should somehow stop it from coming in anymore. Yep, hope that answers the question.
Thanks, Kelvin. Okay, maybe I will ask a question that I also thought was really interesting from our Q&A. So it's from Sherling. So how are IoT devices being identified for research? Are commercial consumer IoT devices also being researched by the CyberSec division in GovTech?
Okay, so maybe I'll answer this. So to be honest, we don't just select any product and just test it. Okay, so it's really dependent on the use case of our project teams that are deploying IoT solutions. So the key thing is that some of these products could be in-house developed and then getting a vendor to manufacture it. There are instances where they actually take use of COTS product and then implant it as part of their infrastructure as well. So we don't just target certain brands or products in place. So depending on the scope of whom we are actually helping to perform that testing, we will then scope it accordingly and then see how can we go about testing for these devices. So hope that answered your question.
Yes, so do our speakers have any other questions? Please feel free to jump in. We really have a lot of questions this session.
So maybe I answer so there's this question from Ek Hong, I think, talking about deleting firmware if there's UART ports connected to it. how do we solve this issue? Then if we come up with the firmware, could be just binary and stuff. Okay, so so I guess what you're mentioning are the readout protections enabled on these hardware chips. So in the market, there are actually very different chips with different features. So there are some chips with the ability to they call it level 1, level 2. So level 1, if you perform some sort of interaction with it, could be the possibility that they delete the firmware and stuff like that. So all these are actually security features that are enabled. Okay, but there are instances that we saw through testings, right? You can actually bypass some of these features that are in place. So it's actually maybe most of the time may not be a foolproof solution, but of course, if there is capabilities as part of what Kevin mentioned, secure designing way upfront is really important. Of course, if there's you really have to plan for security in all aspects, be it the protocol that you're going to use, the hardware features that you're going to have. Of course, find chips whereby they actually have all these features that are enabled on them, so that you can actually deter or prevent attackers from actually conducting further attacks itself. In terms of the firmware, so actually once by starting the data sheet online, you're actually able to see where at which address, location the firmware actually being stored. So if you're actually good, or you understand how to extract data out from hardware devices or hardware chips itself, what you can do is to then set the memory address location. You can actually pull out the entire binary. Okay, but you won't get it way back into the high level language. Most of the time, it will just be SMB codes. So from there, you really have to look at it and try to reverse engineer it. So there are some tools that we often use, like Gira or IDA Pro, that can actually help to perform this reverse engineering. Then from there, what we actually do is to try to identify, insecure coding practices, vulnerabilities, and from there we will attempt to test it out. So yeah, that's how we often go about performing it.
Yes, anyone else? Please jump in. We really do have a lot of questions. Thank you everyone for your questions.
I think maybe I can answer one more, from Anonymous. How can you ensure that your COTS product or commercial off-the-shelf products, like your IoT gateways, are safe to use? I think this question it's a bit similar to, I think, Joyce's question in the beginning. Like she was talking about her smart fridge and whether she can be assured that, maybe her fridge won't open itself at night or something like that. Also, when we come to talk about feeling the assurance or wanting to know whether our products that we buy off the shelf, whether they're safe to use, I think one key thing to do is you have to do your due diligence. So for example, I myself, I'm actually I'm a heavy fan of home automation. I actually from time to time I look around, especially during 3344, all the Shopee sales. I try to find some smart systems that I can bring home and play around and see whether it can help me just to make my life easier. So of course, coming from security background, we will always question ourselves, actually, is it really safe for me to do this? So I think a few things that I like to ask myself is, for one, will they recognize it if I manage to find some bounce and report to them? So I think Keith was also talking about the disclosure program. So if your vendor, if the manufacturer has a very stable disclosure program, then I think you can be more assured to know that, okay, if I were to find something, or if a fellow white hat hackers were to find something, then I think they can report it and then they will do something about it. So at least I know my money is in good hands. And the next thing is, I think I'm also in a privileged position because I have been dealing a bit in IoT pen testing. So if I buy it, I also try to do some testing on it. But for a typical consumer, I think a quick Google search, look around and see whether there are issues surrounding the company. If it comes from a big brand and you know that they have regular patching routines, then yeah, of course, I think we can choose it safely or better compared to unknown brand. Yeah, so that's my take on COTS products.
Okay, to address one question from an anonymous attendee. Oops, sorry. it went off my screen. Good to hear that you are adopting SBD approach during the product development. However, most of the IoT devices meet very basic security controls. Do you have any advice how to protect these IoT devices? To answer candidly, if you know who are those suppliers, please get them to watch this video. Yeah, so that they know how to build it better. Okay, coming back to this question, I guess this would be more from system integrators' point of view. So always approach your use case or the system they're going to build by understanding your requirements. So if your devices are to store certain sensitive information, then naturally don't opt for those cheap type of IoT devices. Yeah, so always go by your risk, identify the risk for your system and your devices, then yeah, just choose accordingly. Because from a supplier's end, it's very difficult to really nail down what security measures or controls they build into their own devices. So I guess it's really up to your own due diligence to go and find out exactly what is within that device. Separately, also just wanted to point out that CSA came up with this the cybersecurity labeling scheme, CLS for short, where they are trying to label IoT devices with a number of stars. So just like how you see your fridge or washing machine with water efficiency, how many ticks, electrical efficiency, how many ticks, they are representing the security with how many ticks, how many stars. So 1 star means not very secure. 4 star means very, very secure in a sense. They just rolled out sometime last year. So they're building more and more on the products, identifying the products to do this labeling scheme. So that's something to watch out for.
Yeah, I think to add on to what Kevin has mentioned with regards to the CLS by CSA, so I think there's this question also on the anonymous asking about, are there any regulations? To be frank, there's actually no regulations for IoT manufacturers today, but I think they are getting more and more initiatives that are getting thrown out today. So the CLS is actually a very, very good example. So, when you talk about level 1, it means that they're trying to protect the hygiene-related issues. So if you go and read out the details, what it means level 1 is just basically that, you must make sure that the consumers always change their default credentials. They must support for the support of reported vulnerabilities and stuff like that. So, if companies actually have that labeling, right, that actually could indicate a better, they actually help to eliminate some of these issues. And like what I mentioned in one of the previous Q&A is that, companies that actually support the, vulnerabilities that are reported by the public, or it's actually something that I encourage, because what they mean is that they have a proper program to update firmwares on the fly. If they discover a vulnerability that was reported, they will fix it, and then they will push out patches to consumers as well. So it's actually a very good initiative. So hopefully more and more companies will actually go through such things, or if there are more regulations coming out in the future. So I guess that's one step that what we are actually doing.
Thanks, Keith. So do we have any other questions that our speakers would like to answer live? If not, it's also okay, because just for our speakers as well as our people, all of our committee members on the call right now, our speakers will be on the StackX Telegram chat for about a week after this meetup. And they will also be selecting some questions to answer there as well. So don't worry if you haven't had the chance to answer your questions, ask your questions, or to answer the questions. So no worries about that. Maybe I will ask our speakers to each take a last question before we wrap up our session this evening.
Sorry, can we go first?
Okay.
Okay.
I see a question from Kelvin Low. How shall we handle key rotation, symmetric, asymmetric keys on IoT devices? Okay, so one way is actually, since you already have your hardware proof of trust key in your device, use that to establish that secure comms to your backend. Then send your new key over. Of course, it has to be authenticated. So you make sure you authenticate the device and send the key over. Update the key using your the same way your bootloader does. Overwrite it into, okay, don't overwrite it. Sorry, I take that back. Put it into a different key slot where it's secure. Make sure that you establish that that the key actually works. So you do a verification back to your server. Then once that's done, you can throw away the old key. So that's how you actually look recycle you to handle your key rotation for IoT devices.
Vin,
Okay, yeah, I think I can take another question.
Sure.
This
Thanks,
question is
Ting Long.
from Hong. So, any example of vulnerability in wireless protocol? Okay, I think this question is a bit generic. So maybe I just share some of my opinions on the bounds related to the wireless space also. So I think in IoT, when we talk about wireless, I think some common technologies might ring a bell to you, be like Wi-Fi, Zigbee, Bluetooth, and then within Bluetooth, there's also like Bluetooth Smart, or Bluetooth Low Energy or Bluetooth Classic, and also things like LoRaWAN and NFC. So maybe just to share a bit more about wireless and its security problems, a few categories of bounds I can think of my mind would be, for example, I think DOS attacks, information disclosure, and I think protocol weaknesses. So I think even though there are many types of wireless protocols, but actually more often than not we will see they actually have similar problems behind. So I think one example I can think of would be let's talk about like protocol weakness. So maybe in, let's say, uh, in Bluetooth, I think in Bluetooth Low Energy, I think if you can do a bit of a quick googling on Bluetooth Low Energy's security problems, I think you will notice that I think one very commonly known problem is the way it used to establish authentication and encryption. So because of the way it was designed, actually, it's very easy for attackers to break the handshake mechanism and then just void out the whole protection scheme. Yeah, so that's just one example of vulnerability in terms of the wireless space. Yeah, I can share more of it in the chat. Just share some things later.
Great. Thanks, Ting Long. So Keith, you will be the one responsible for wrapping our session up.
Okay. Let's see. Okay, so I think there's a very interesting question about how to reduce the chance of being hacked. What's the best practice that your team would recommend? So I mean, it really depends on coming from which angle. Are you trying to protect an organization or from your home? I think the risk level would differ also, like what Kelvin mentioned. And also, like I think in my slide, I also mentioned that if you're operating in an OT environment, then the risk will be higher. So of course, if there are higher risk impact that there is, right, then the likelihood of you needing it to secure will definitely be higher. So what are some best practices? It actually varies and depending on what technology you use. IoT is not a very simple topic that we can just say, there's a one-size-fits-all solution. Depending on the protocol that you use, the design of it, there's a lot of considerations that go behind. So even your infrastructure, your networking, how do you ensure that all the, basically what Kelvin shared, all the keys that you use for your encryption, how do you secure the communication? There's actually a huge load of considerations that have to go into it. So depending on what you're looking at, then maybe it's best that we can advise you from there. So yeah, I mean, if you have any questions, then more particular to which kind of environments, then we can actually answer it in the Stack chat in the Telegram.
Thanks a lot, Keith, and thanks a lot, Kelvin, Jinglong, as well as Ronghua for your sharing today. So this is finally the end of our Q&A. I know that we still have a lot of questions. So our speakers will be in the StackX Telegram chat, which we've mentioned before. And they will be there for about a week to answer questions that they have selected. So I'm actually now sharing the link of our StackX Telegram. So please join and you can continue to chat with our speakers then. So a big thank you to you, everyone, as well, for joining us tonight. Do let us know how the webinar went by scanning the QR code that our slide will be up in a bit to give us your feedback. And perhaps I'll share the link to the survey at the moment. So this is just the link to our survey. Do let us know how it went, what you like and what you thought that we could do more of so that we can improve further sessions for you guys. And so that wraps up our StackX meetup tonight. So as mentioned, if you have questions, just join our StackX Telegram chat, and that's been shared in the chat right now. So I think we might have a little bit of technical issues with the slides. So let me just share one last link for everyone. Yep. Okay. So this is actually the jobs portal link that we have for the government during this period of COVID. Oh, great. The slides are up. Yes, thank you, Candy. So during this period of COVID, we would really like to support the tech community that we are all part of. So we have close to 400 positions available for both contract and perm roles. So whether you are a software engineer, a DevOps engineer, QE or BA, you will be able to find some interesting roles here. And if you do know of any friends who may be keen or have been displaced during this period, please share this link or QR code with them. And that wraps up our session for tonight. Thank you again for joining us. And of course, a big thank you to our speakers as well. Thanks, everyone. Good night.